Okay, we have already learnt about identity element, right? Identity element is like if you operate any element with identity element, you will get same element, right? Now we will talk about inverse element. So in any set, suppose there is a element which is known as B, and if you operate that element with A, and if you get E, what is E? E is my identity element. If you get E, then B is basically known as inverse of A, right? Inverse element means when it is being operated by the element, then you get E as an identity, right? So for example, if you talk about addition operation, okay, in addition operation our identity element E is 0. Why? Because any number with 0 addition will give you the same element. So 0 is my identity element. Now we want to find the inverse of this addition. Okay, so that is basically known as additive inverse. Since it is the inverse of the operation addition, we call it as additive inverse. So additive inverse of 3 is what? If you, let us say B is my inverse of 3, which will give you what? Your identity element, which is 0. So what is B here? -3. So in addition operation, the negative of the number is basically our inverse element, right? And it is known as additive inverse. Now same, we can apply same logic to multiplication also. In multiplication, our identity element is what? 1. Why? Because if you multiply any element with 1, you will get the same element. So we have identity element 1 as in multiplication. Now now we have to find the inverse. So here also it is called as multiplicative inverse, right? Suppose that element is B. So if I multiply, we should get what? Our identity element, which is 1. So what is B? 1 upon 3. So in multiplication operation, the reciprocal of the number is known as my multiplicative inverse, right? So similarly, we can find out the inverse element in any operation, right? Now suppose in the earlier examples where we have taken an operation like A star B is equal to A plus B minus BC. This was my earlier operation. Now we want to find whether we have, this was what? This was, and the set for this was like rational number minus 1. Okay. So we want to find the inverse element of this. If you remember the identity element, what was that? It was 0 only. Why? You can try it here. A star 0 will give you what? A plus 0 minus 0 into A, sorry, not A, B, C, it is A, B. 0 into A, which will give you A, right? So this is my identity element. Now we want to find inverse. So let us take another example here. A star B. A is my original element and B I am taking as an inverse element, and we will find out what is B with respect to A. Now this is what by definition it is this much, but from the definition of inverse element it should be equal to what? 0, because we will get the identity element. So let us find out. So we want to find B, so it will be like A is equal to AB minus B, or if we take common, so B is equal to A upon. So inverse of element A is basically what? A upon A minus 1. This is my B. So our inverse element in this process, in this example, is A upon A minus 1. So whenever you need to find out the inverse element, what you will do? You will just take one element A and operate it with B. B will be what? The inverse of A, and first you write the definition part and then equate it to the identity element. In this case E was 0, so here also I have taken E is equal to 0, and then we need to find B in terms of A to get the inverse element, right? Okay, let us take one more example in which we will find both the things, identity also and inverse also. So this is the question that A star B is defined as A plus B plus 1. A and B both belongs to integer family. Okay, so first we will find out our identity element. So let's say our identity element is E. Okay, so by definition it should be A star E should be equal to what? A. So, and by definition it should be A plus E plus 1 to A. So here A is minus 1. So we have got our identity element which is minus 1, right? Now we need to find our inverse element. What is your inverse element? Inverse element, let's say it is B. So what we will get? A star B should be equal to what? Our identity element, let's say. So here A plus B plus 1 should be equal to what? Minus 1, because E is our minus 1. So what is B? Correct. Now we need to check whether this B is coming in our set or not. Okay, we are saying A and B belongs to integer. We need to check B whether B belongs to integer or not. Of course, A is my integer, 2 is my integer. Addition of two integer will always give you an integer, and negative of that integer is again an integer. So B also belongs to integer. It means A inverse is equal to minus 2 plus A. So this is my inverse element and this is my identity element. Okay, now we will talk about composition table in binary operation. It is nothing but operation of any two elements in the representation of any two elements in the form of table. Okay, let us see how it works. Suppose we have a set where we want to find the operation, binary operation, which contains three elements. Suppose we have three elements and our operation is suppose star, right? Now what will happen? The star operation can be done like A star A or A star B. We can choose any two elements since it's a binary operation. So we can choose any two elements and operate it with this operation. Okay. Now we want to make a table where on top of the row I'll write all the elements, left also I will write all the elements. Okay, and here we will put our symbol of the operation. Correct. Now what will happen? In first row, first column, I will get A star A. What will be the value of this operation? Then second column and first row it will be A star B. Similarly, it will be A star C. Second row first column will be B star A. Okay, because we are operating from here now. B star A, B star B, and B star C. Right. Similarly, we can write it C star A, C star B, and C star C. Right. So this is called as my composition table. Now from the composition table, we can conclude three things. Right. First is closure property. Whether this operation is binary or not, we can find it out from the table itself. If all the elements here is from the same set S, then we can say it is a binary operation and it follows a closure property. Second, commutative property. Right? Commutative property, if my first row is equal to first column, then we can say that the operation is commutative. Similarly, second row should be equal to second column. Right? How so? Because my first row contains A cross A, A cross B, and A cross C. Right? If this is equal to my first column, then A cross A is equal to A cross A, no issues. A cross B should be equal to B cross A, hence commutative. A cross C should be equal to C cross A, again commutative. Similarly for the any row, second row and second column, if I try second row and second column, if I take first element is A cross B, B cross A, both are equal, right? B cross B, same. B cross C, C cross B, these two are equal. So if the corresponding row and the corresponding columns, elements of those column and row are equal, then we can say it is commutative. Okay. Third, we can identify the identity element. Okay, suppose if here you get A, here you get B, here you get C. So clearly we can say that C is my identity element. Why? Because we are operating A by C and getting A, B by C and getting B, C by C and getting C. Similarly, if you operate C by A, you will get A, B, and C, like this. So by looking at the table, you can find out these three things easily. Let us solve one example here. Right, so this is my example. We have set A, which includes a number like 1, 2, 3, 4 and 5, and we have an operation which says minimum of A and B. So whenever we take two elements, whatever the minimum value is there, we need to write that value. For example, if you take A and B as 2 and 3, right? So 2 star 3 will give you 2 minimum value, right? So let us operate this operation here. Okay. If you take 1 and 1, what we will get? 1 star 1 minimum is 1. 1 star 2 minimum is 1. 1 star 3 minimum is 1. So 1 is the minimum in all the cases. For second row, 2 star 1 we get minimum as 1. 2 star 2 will get 2. 2 star 3, now for all I will get 2. Similarly, we can write 1, 2, 3. 1, 2, 3, 4. Correct? Now let us find out whether it is closer or not. See, all the elements belongs to same set 1 2 3 4 5. So closure property it follows. Second, commutative. Let us check. This is my first row, first column, same. Second row, 1 2 2 2 2. Second column, 1 2 2 2. So first row is equal to first column, second row is equal to second row column. Similarly, you can find third row will be equal to third column, fourth will be fourth, fifth will be fifth. So we have commutative property also here. Third, inverse. Sorry, identity, not inverse. Okay. For identity, we need to check what. See, if you 1 operated with 1 getting 1, 1 operated 2 getting 1, right? So 1 operated 5 getting 1. So basically, if you look at it, this row, sorry, this column and this row, this is giving you the same element. 5 operating with 1 giving you 1. 5 operating with 2 giving you 2. What is the definition of our identity element? That A star E is equal to E star A should be what? A. So if you look at this, A star E, 1 star 5 giving you 1, 2 star 5 giving you 2, 3 star 5 giving you 3. So we have an identity element here, and that is equal to 5. So we have identity element as 5, right?